We pray. Heavenly Father, I want to thank you for this morning. I want to thank you for the knowledge that you are going to provide us, loving Father. Thank you, loving Father, for keeping us throughout the night as we are going to study. May you come and be with us and we understand whatsoever that you are going to be taught. In the mighty name of Jesus, I pray and believe.
And
Amen.
uh, thank you so much for the word of prayer. Good morning, everyone. Thank you so much for joining. We are going to start our session. And today, our focus is going to be on trigonometric identities. So that is going to be our area of focus in our session today. Now, when we talk about trigonometric identities, we are looking at those equations that involve trigonometric functions, which hold true for any angle that you put within that particular equation that you have. In our session today, we are going to learn how do we derive those trigonometric identities. So our major focus in our session today is going to be on deriving the trigonometric identities. So we are going to derive, and at a later time, we are also going on to prove those identities. So how do we start, or where do we start from? Now, yesterday, we looked at our trigonometry, and we say that in our trigonometry, when I have these are our quadrants that we have divided into 4 equal parts. Now, we know that the distance from the center here up to any point that touches the circle, how do we call that? Put for me in the chat. How do we call that? How do we
Hypotenuse.
call that distance? I want this distance here. How do we call it? Hey, from your mathematics. Thank you, HP. HP has called it is the radius. Very good. So this is our radius, which I can call R. Now, from our radius here, you notice that I can come up with a right angled triangle. And this is what we looked at yesterday, and we looked at the reference angle. So we are going to build up from there. Now, dear members, if I have this as my triangle. Let me say this is my triangle that I have. And I have my angle here as theta. This one, I'm going to be calling it R. In all what we are going to do, I'm going to be calling it R. You know very well that what along this is my Y, and you know that this is my X, or the X values. So if this is my angle, you know very well that the side that is opposite to my angle is what we always call the opposite. And this one is always our hypotenuse, and this one is always our adjacent. Now, in case I'm interested in obtaining sine of theta, you know very well, always do not forget that we have what we call SOHCAHTOA. So our sine is going to be our opposite divided by the hypotenuse. Now, for our case, what we have here, it means that our sine theta is going to be opposite, which is y, divided by hypotenuse, which is r. Now, what is my value for y? You notice that when I cross multiply, my y will equal to r sine of theta. Members, through the chart, is that step fine? The first one for y. Is it okay to everyone? Type in the chat, no problem. Ruth says yes. Okay, people are saying yes. Very good. Now we go to cos. Now, what about when I have cos? So we know that cos of theta is given by adjacent out of the hypotenuse. So what does it mean? It means that cos of theta is equal to my adjacent, which is x out of hypotenuse. Members in the chat, tell me, what is my x equaling to? What will x equaling to? What is x equaling to? what is x equaling to? I want you to give me that expression like the way we have given for r. HP has said r cos theta. Is everyone saying r? So this will be r cos of theta. That's the meaning. How are we getting it? We are multiplying. When you multiply r this side. So you end up with r cos theta is equal to x. So that is the distance x in terms of the radius r and in terms of our angle. Now, from here, we are going to continue now. Daniela, what's the question? Daniela, ask. Okay. Daniela, ask. Okay. So after obtaining our x, we are coming back to our triangle. Now, members, you know very well from Pythagoras theorem that I have a squared plus b squared is equal to c squared. Now, you know very well that from Pythagoras theorem, A stands for any side as long as it is adjacent or opposite. Now, for our triangle we have here, my adjacent has length x. So I'm going to put here that this is x squared plus my b, which is the y, has y. So this is going to be y squared is equal to c. And my c from the triangle is r. So this is going to be r squared. Now, what are you noticing? From here, we have obtained that our y is the same as r sine theta. So where there is y, we shall put r sine theta. Where there is x, we shall put r cos theta. So we shall come here and substitute that x is the same as r cos of theta squared plus our y, which is the same as r sine theta squared, is equal to r squared. Now, mathematically, you know that when I have r cos theta, everything squared, this is the same as r cos theta times r cos of theta. So what shall we have? R times r will give us r squared. Cos theta times cos theta will give us cos squared theta. So it means that here I'm going to remain with r squared cos of squared theta plus r sine theta. You do the same thing. That what is r sine theta? R sine theta, everything squared, means r sine theta times r sine of theta. R times r is r squared. Sine theta times sine theta gives us sine squared of theta. So here we shall put r squared sine squared of theta is equal to r squared. Members, are we still on the same page? Are we still on the same page? Okay, Ruth says yes. Okay. Yes. Okay. Now we are going to continue. Now, when you look at what we have here, you notice that r is common here. You notice that r is common. R is here, r squared, and also r squared is common here. Meaning that r squared is a common factor. So when it is common, I can pull it out. So I can say r squared into cos squared theta plus my sine squared theta is equal to r squared. Now, you know from your mathematics that whenever I have, let me say 2x is equal to 4, to remove this 2, I will divide by 2, I divide by 2. So I end up with x is equal to 2. Even here, r squared is common. So I'm going to divide this side by r squared, I divide by r squared. Members in the chat, r squared divided by r squared, what do you get? R squared, HP says 1. Members, do you agree you get 1? R squared, very good, you get 1. So in other words, this and this will cancel, this and this will cancel, and you get 1. So members, I want to bring it to your attention that now here we are going to remain with our cos squared theta plus sine squared of theta equals to 1. Members, this is an important identity in trigonometry. So this is one of the identities you need to have of head every time. Whenever you have cos squared theta plus sine squared theta, your answer will always be equal to 1. Take note, that is the first identity for today. Yes. Yes, Daniela.
Teacher, morning.
Morning.
Teacher, can you please repeat from the quadrant?
Daniela, did you attend yesterday's session?
Yes, teacher, I understood because I know the quadrant, but I just want you to repeat a little bit.
Which part?
For this first quadrant here.
Like I was just telling them that if I have a quadrant is like a circle. So anything I draw from the circle, from the center of the circle to this, makes my radius r. That's what I was using the quadrant for, to just show them the r.
Okay, thank you, teacher.
Yes, but for whatever quadrant you use, you get this relation like that. Okay, that is the very important relation we must always have. So now I'm going to give you examples. I want you please to take note that even if you have on your calculators, members, you place this sine squared 30 plus cos squared of 30. Which answer do you get on your calc? Place it on your calculator. Place it on your calculator. What answer do you get? Place it in the chat. Okay, from the chart, members are getting 1. So members, whenever you meet these trigonometric relations, as long as you notice that the angle here is the same and the angle here is the same, your answer will always be 1, as long as it is squared. Even if I have sine or sine squared of A plus cos squared of A, your answer will always be what? 1. Take note of that. This is an important relation. Anything we are going to do going forward, this relation is going to be appearing often times. So from today onwards, have it at the fingertips. Okay, that is the first one. Now we continue to the second one. Then the second one, the second identity we are going to look at, we are going to start from where we have ended. So we have noticed that sine squared theta plus cos squared theta is equal to 1. Now, what is going to happen? Now, in case I have this relation and I divide throughout by a common thing, say I divide through by cos or I divide through by sine, what will happen? So I have sine squared theta, I'm dividing through by a common term. So divide by cos squared theta plus cos squared theta divide by cos squared theta is equal to 1 out of cos of squared theta. So when you look at what I've written here, I have not changed anything. It's like mathematical. If you have x plus 2 is equal to 3, if you divide here by 2 by 2 by 2, you have not changed anything. It is the same equation. Even if you divide by 3 by 3, even if you have x plus 2 is equal to 3, and you divide here by 2 squared, 2 squared, 2 squared, you have not changed anything. Now, what do you get? Now, you remember, when we are starting, we say that when I have sine theta divided by cos theta, we say that this is the same as tan theta. Now members, if I have sine squared theta out of cos squared theta. This is the same thing as tan squared theta. In other words, when you square this side, you can as well square this side. So once you square, you get this result. So where there is sine squared theta out of cos squared theta, this is the same as tan squared of theta. Plus cos squared theta out of cos squared theta is 1 is equal to, still we learned that if I have my sec theta is the same thing as 1 out of cos of theta. But when I square and I square this side, I'll have this side my sec squared theta equals to 1 out of cos of squared theta. So whenever you find sec is the same as cos, is in the same as the reciprocal of cos. So meaning that where I have 1 out of cos, this is the same thing as sec squared of theta. Now this one, you can even write it like 1 plus tan of squared theta is equal to sec squared of theta. Why am I bringing this? Because some of you can easily add up this, which is not mathematically correct. That's why I prefer starting with this one, then I bring the trigonometric function. Now members, I want to let you know that this is our second identity. Yes, this is identity number 2. So whenever they ask you what is 1 plus tan squared theta, you must be able to know that that is sec squared theta. Why are we bringing them now? You are going to be meeting integration. You are going to be meeting differentiation. These identities are going to be key. These identities are going to be very important. So this is identity number 2. Can you write and we continue? Okay. Are we good to continue, members? Let me know through the chat whether we can now proceed. Okay, Mass says yes, Edgar says yes, Anita says yes. Okay, so we continue. Identity number 3. Identity number 3. Now, still from our start, we say that when you have sine squared theta plus cos squared theta, this one is equal to 1. Now, what about when we divide by sine squared? What shall we have? So, in case I divide by sine, I'll have divide by sine squared theta plus our cos squared theta divided by sine squared theta is equal to 1 divided by sine squared theta. Now, sine squared theta divided by sine squared theta is 1 plus, you remember we looked at the yesterday when we are starting, we know very well that when I have cot theta, this is the same as cos of theta divided by sine of theta. Now, what about when I square? So when I square this side and I square this side, it means that I'll have cot squared theta equaling to cos of squared theta divided by sine squared of theta. Now, where there is cos out of sine, I'm going to replace it with my cot. That is the meaning. That where there is cos out of sine, you are going now to put your cot. So I'm going to come here and I say, now this is cot squared theta is equal to, also remember, we say that when you have cosec theta is the same as 1 out of sine of theta. But in case it is squared, I will square this side. I also square this side. So meaning that cosec squared theta is the same as 1 out of the sine squared theta. So where there is 1 out of sine, we shall put our cosec squared theta. And members, allow me to let you know that this is our third identity for today. Yeah. The first identity was sine squared theta plus cos squared theta is equal to 1. Why are we dividing? We want to get more identities. So I'm showing you how different identities can be reached at. Okay. Members, are we on the same page? Okay, Mass says yes. Gertrude says yes. Uh-huh. Okay. Very good. Very good. Now we are going to start proving the identities. The next thing we are going to look at is going to be proving the identities. So we are going to start proving. The number of identities we have in trigonometry are many, but now I've given you, this is the foundation. And for trigonometry, once you understand the foundation, other topics are going to become easy. Integration is going to become easy. Differentiation will become easy. Numerical methods will become easy. Things of dynamics will become easy. Those who are doing physics, waves is going to become easy. So it's going to cut across all areas. Yes, that's why you need to take it and practice as much as you can. Yes, Dorothy.
Morning, Teacher Stephen.
Morning.
I'm sorry to take you back, but can you please repeat something on identity one
Identity 1. Which area on identity 1?
about how we get sine squared theta plus cos squared theta and get 1?
Did you understand this part here?
Yes, I did.
Then this.
Yes,
Then this.
I know.
Yeah, because from this point here, we say that once you square r cos theta and you square it, it means you are going to have r cos theta times r cos theta. But r times r is r squared. Cos theta times cos theta is cos squared theta. So that's how we get this part here. The same thing will happen on r sine theta. But at the end of the day, r squared cos squared theta plus r squared sine squared theta is equal to the r squared we have this side. Now here you notice that r is common, r is also common. So you remove it, you factor it out. So by factoring, you have cos squared theta plus sine squared of theta is equal to r squared. Now, to remove this r squared, I will divide by r squared, divide by r squared. This and this will cancel. So you remain with cos squared theta plus sine squared of theta. R squared divided by r squared is a 1. So that's how that identity comes about. Okay, now it is time to start proving the identities. So number 1, we are only going to be working with proving. Now, the first one, we are going to say proving the trigonometric identities. Proving of these identities. So, the first one we are going to look at, we have the first one, they are telling us to prove that sec theta plus cosec theta cot theta is the same thing as sec theta cosec squared of theta. That is what we are proving. Now, as we are proving these identities, I want you always at the back of your mind know what each of them mean. When you find sec, sec means 1 out of cos. When you find cosec, you know that cosec theta means 1 out of sine of theta. When you find cot theta, cot means cos theta out of sine of theta. Number 2, when it comes to proving, what does it mean? It means that someone can come from the left-hand side. This is the left-hand side. This is the right-hand side. Proving means that show that either the left-hand side is the same as the right-hand side or the right-hand side is the same as the left-hand side. That is what you have to do. So meaning that at the end of the day, you must be able to show that what you have on either your left or right is the same thing with what you have on your right or left. So that is where we are starting from. So we are going to start now applying. Now where there is sec theta, like we have said, sec means 1 out of cos of theta plus what is cosec? We have said that cosec means 1 out of sine of theta times what is cot? Cot is the same as cos theta divided by sine of theta. That is the first thing. Now you work it out. So here we shall remain with 1 out of cos of theta plus 1 times cos theta, we get cos theta, divide by sine theta times sine theta will give us a sine squared theta. Now this is where you bring in your mathematical thinking, because at the end of the day, whatever thing you are going to be doing must give us what we have this side. Number 2, algebra here is key. Knowing algebra, knowing how to deal with fractions is key. Now, when you look at our denominator here, we have cos theta, we have sine squared theta. Now, what is our LCM? Now, the LCM is going to be cos theta, sine squared theta. But sometimes I always let you people know that if I have 1 out of A plus maybe 1 out of B, you can do it mathematically easy by having this one multiply here, such that you get 1 times B plus have this multiply here, say that is A times 1. Then what you have down here, just multiply A times B. So you are going to allow me to use that math, that this sine squared theta can multiply here. So what shall we have? We shall have 1 times sine squared theta plus this and this will multiply. You get cos theta times my cos of theta. Divide by, I multiply with what I have down, cos theta and sine squared theta. But in case you don't want to use that root, for you say, what is my LCM? My LCM is cos theta sine of squared theta. Then you say cos theta sine squared theta divided by cos theta. You get sine squared theta times 1. So you end up with sine squared theta. Then you get cos theta sine squared theta divided by sine squared theta is cos theta. So what are we going to get? You'll get cos squared theta. So you can approach it in that way. Whatever approach you want, you get the same answer. So 1 times sine squared theta, members, you end up with sine squared theta plus cos theta times cos theta gives us cos squared theta. Divide by our cos theta sine of squared theta. Now, I want you always, when you look at the numerator, look at what we have in the numerator. When you look at what we have in the numerator, we have sine squared theta plus cos squared theta. Mathematically, in the chart, tell me, what are we going to remain with in the numerator? What is sine squared theta plus cos squared theta? What is your answer when you add that identity? Which answer do you get in the chat? Quickly. Very good. People have noticed that that is a 1. So meaning that where there is sine squared theta plus cos squared theta here, we are going to replace with a 1. So we shall now remain with 1 divided by cos theta sine squared theta. But look at where you are heading. Where you are heading, you have a cosec. You have a cosec. So now I'm going to come here and I say that you know very well that when you are dealing with fractions, when I have 1 times 2, 3, it means I can have 1 out of 2 times 1 out of 3. You know it very well. So here I'm going to separate and I say This is the same thing as having 1 out of cos theta times 1 out of sine squared theta. Then you remember, what is 1 out of cos? 1 out of cos is sec theta. What is 1 out of sine? 1 out of sine, you know that 1 out of sine is the same as cosec theta. But in case it is squared, it means you square as well. So 1 out of sine squared theta is the same thing as cosec. So here I'll have my cosec squared theta. And you have proved that the left-hand side is equal to the right-hand side. Okay. Yes, Bridget?
Master, I'm just inquiring. Is identity the same as rules?
Is identity the same as laws? I want to say,
The same as rules.
yes. Okay. Now, what is the difference between the two? The difference between an identity, if you take it in the mathematics angle, an identity is the statement that shows equality, that those two things are equal, that something is true for all different values. While when we talk about a rule is like a formula, is like is like a conditional equation. It just describes the relation or the process of carrying out something. Hope you have got the difference. Eh, an identity is an equation that holds true for all different values, regardless of which value you substitute in. That for it to be called an identity, whatever value I substitute in here, whether I have put in 50, here I have put in 50, 50, the answer I'm going to get this side is going to be the same answer. If I put 50 and 50 here, it's going to be the same thing. That's what we call an identity. But when I talk about a rule is just a statement. It's like a formula that is true, but for certain values. An example uh, of a rule, when you put in, let me say, when you put in 2, it can be true. When you put in another value, the answer may not be true. That's what we call a rule. A rule is like those indices. Those are what we call rules. Indices, you know that, let me say in indices, that addition, okay, a times m times a power n is equal to m plus n. Now, this is what we call a rule. But a rule, if you put in different values here, so it just describes the behavior to help you to get unknowns. That is the meaning. Let me hope you have gotten the difference between what we call an identity and what we call a rule. So you are going to allow me that now we are going to go to the second identity. Yes, Daniela?
Teacher, why is it when we're proving
Mm,
on the quad theta, why
mm.
couldn't you not say 1 out of tan theta, but we said cos theta out of sin theta?
It is the same thing. So 1 out of tan theta. You are going to go back and say, but what is tan theta? Tan theta is sine theta out of cos theta. When you do the mathematics, it becomes 1 divided by sine theta out of cos theta, which now will end up with 1 times cos theta out of sine theta.
Thank you, teacher.
Okay, yeah. Okay. Emma? Yes? Okay. Identity. We are going to look at another proof. We are going to look at another proof. Now, the second one, now, when it comes to proving something, I want you to take note that you can come from one side and you go the other side. But always you may find that there is an easier way to reach one side than the other. That one you should have it in the mind. That always there is an easier way. That is for the proof that you either one side is much easier for you to come from here or to go the other side, or it might be easier to come from the left, you go towards the what? The right. So you need to see or to check out mathematically which side may be easier for me to come from and where can I go. So identity number 2. Sine squared theta into 1 plus sec squared theta is equal to sec squared theta minus cos squared theta. What does it mean? Always, whenever you meet, it is the choice is yours. Either you move from the other side, go this side, or you move from the other side, go the other side. But whatever route you take, as long as you're sure that one side is equal to the other. So, okay, now we are going to start. Now we are going to open our brackets. I'm going to start from my left-hand side. So I'll open up my brackets. I'll have sine squared theta times 1 plus my sine squared theta times our sec squared theta. That is the first thing. Now sine squared theta times 1, you end up with sine squared theta. Then plus our sine squared theta and sec squared theta. Now, when you are revising or when you are proving these things, always have a mathematical eye. Where are you heading? What destination are you taking? And in case you are dealing with sine, make sure that you first have your things in sine. In case they are in sine cos, that is okay. But don't mix sec and cosec, sorry, sec and sine. So you can first have them all in one angle. So here we are going to continue and say now we shall have sine squared theta plus our sine squared theta. But we know that sec means 1 out of our cos squared theta. That is our sec. So what shall we end up with? We are going to have sine squared theta plus sine squared theta times 1 out of that is the same as sine squared theta out of cos of squared theta. Now, from your mathematics, you know very well, or we have already said that when I have sine out of cos, that is the tan. So we shall end up here with okay. We are going to end up here with, we are going to end up with sine of squared theta plus our tan squared theta. Now you have to think quickly. You ask yourself, where I'm heading there is sec, there is cosec. How am I going to bring in that idea? Now you go back to the identities. Remember we said that 1 plus tan squared of theta is the same thing as sec squared theta. But what is tan? Because here I have my tan, that I can have my tan squared theta as sec squared theta minus 1. So where there is tan squared theta, I can substitute with sec squared theta. So I'm going to come here and I say now I have my sine squared theta plus my sec squared theta minus a 1. Now, when I reach here, you must always be able to think. You ask yourself, in math, you remember that what is 1 in trigonometry? How do you reach at 1? You know that to get a 1 means sine squared theta plus cos squared theta is equal to 1. Now, where there is a 1, I am going to substitute with this. So I'm going to come and I say now that this is sine squared theta plus my sec squared theta minus, where there is 1, we are going to put sine squared theta plus our cos squared theta. Now you can open the brackets, you get sine squared theta plus our sec squared theta minus sine squared theta minus the cos of squared theta. But you have here already your sine squared, you have here your sine. This is positive, this is negative, meaning that these two can go away. And once those two go away, you remain with your sec squared theta minus cos of squared theta, the way we have it this side. So that is how you prove that. So that is how you can move from one side and you go to the other side. But whatever side you use, you can move from the one side to the other. But it will always require some critical what? Some critical thinking. You need to critically think that if I do this and this, what will happen? So that is how you can approach that in that angle. So let me first pick a hand as yes, Marie.
Mm. Good morning, sir. So like here
Morning.
on 1 plus tan squared theta is equals to
Mm.
sec squared theta. Is that an
Mm.
identity or a law?
Yes, that is an identity.
Mm. Okay
Eh,
then.
okay. Daniela?
Teacher, on the
Yeah.
sine squared theta plus
Mm.
tan squared theta, how did you bring
Mm.
out the 1? Because I never understood here how you got 1 plus tan squared theta is equals to sec squared theta.
No, this is an identity. We looked at it. Look at your identity number 2. This was an identity. Hope that is
Yes,
okay.
yes.
Yeah. Aaron? Aaron?
Pastor, good morning.
Morning.
I wanted to inquire from you where we expressed, can you also express tan sine squared theta in terms of cos squared theta and we get the same answer?
Can you express? Yes.
Sine squared theta in terms of
Mm.
cos squared theta. Shall we also get the same answer?
Yes, the answer will be the same. Yes. You can use
I'm
that.
not.
Okay,
Oh,
now the second approach, for those who want the second approach, remember we had
yes.
remained with sine squared theta plus tan squared theta. So someone is asking, is it possible if you express your sine squared theta in terms of cos? So remember, members, we know that sine squared theta plus cos squared theta is equal to 1. But since our answer has already cos, we can make the cos here. So sine squared theta here, when you make it the subject, means you'll have 1 minus cos of squared theta. Now where there is sine squared theta, you can place 1 minus cos. So I can have 1 minus cos squared theta plus my tan squared theta. But you go back and ask yourself, what is this tan? You know that tan, 1 plus tan squared theta is the same as sec squared theta. But I want tan, so I take the one the other side. So that means that tan squared theta is the same thing as sec squared theta minus 1. So that means where there is tan, I'll put this. So you can come and say 1 minus cos squared theta plus sec squared theta minus 1. So 1 minus 1 is 0, so you end up with negative cos squared theta plus our sec squared theta, which you can now write it in a good way as sec squared theta minus cos squared theta. So you can as well do it like that. There's no problem. Okay. Okay. Last one, Mari. HP. Okay, I think I failed to get Mali, so we can now go on. But like I've said, if you want, you could as well move from one side to the other, as long as you know how to play with the identities. Okay, so I can move on and we do number 3. Number 3, which identity can I bring? Okay, number 3, I can have this identity that sec squared theta is the same thing as cosec theta out of cosec theta minus sine of theta. Something like that. Now, like some of you want to come from one side to the other, it is very okay. So someone could come from either left-hand side and you go to the right-hand side. Or you come from the right-hand side, you go to the left-hand what? Left-hand side. But here I'm going to do both. Yeah, but like I've said, the thinking, the thinking is different. When you are coming from the left-hand side to the right-hand side, you may find that the thinking is okay. When you are coming, you may need to think further. So let me start from the right-hand side, and then I can do the left-hand side. So let me put here that I'm going to start from the right-hand side. So right-hand side, I have my cosec theta out of my cosec theta minus sine of theta. But you know that cosec is 1 out of sine. So you say this is 1 out of sine theta. Divide by cosec, which is 1 out of sine of theta minus sine of theta. Now, when you look at my denominator here, I can first write it in a simple way. That this is 1 out of sine of theta minus sine of theta. But what is my LCM? This is like out of 1. My LCM is sine of theta. Now I will say sine theta divided by sine theta is 1, then times 1 up. Minus sine theta out of sine, this is 1 times sine theta, you get sine squared of theta. Now, mathematically, this is what we are going to have. So we are going to substitute. So you are going to allow me that the denominator, I will substitute with that. So here we shall continue having 1 out of sine of theta divided by 1 minus sine squared of theta out of sine of theta. Then you do your algebra that this is 1 sine of theta divided by 1 minus sine squared theta out of sine of theta. So which will be 1 out of sine of theta times sine of theta out of 1 minus sine squared of theta. So the sine and the sine will cancel, so you remain with 1 out of 1 minus sine squared theta. Members in the chat, what is 1 minus sine squared theta? Put it in the chat. What is 1 minus sine squared theta? 1 minus sine squared theta. What do you get? Mali, you're giving us an answer? Thank you, Hannah. Yes, it is cos squared theta. Very good. So meaning that now that identity, you have to come back here that sine squared theta plus cos squared theta is equal to 1. So when I take the sine this side, I'll remain with cos squared theta equaling to 1 minus sine squared theta. So where there is 1 minus sine, we are going to place cos squared theta. So members, now you'll agree that we are going to end up with 1 out of cos squared theta. But what is cos? Cos is sec, and therefore shall end up here with sec squared theta, which is the same thing there. Yeah. So that is how you can do it coming from the other side. Yes. Yeah. So here, identities, those are the things we are playing with. Genesis.
Good morning, sir.
Morning.
Sir, could you just please pardon for this part of the right-hand side?
Where?
Okay, there is this part you've asked that what's like 1 minus
Here,
sine
down.
theta. Yes.
Yes, I have showed it here, Genesis. From this identity, the first identity, that sine squared theta plus cos squared theta is 1. But when
Yes.
you make cos squared the subject, you'll get 1 minus sine squared theta. So where you have 1 minus sine squared theta is where you replace cos squared theta.
Oh, okay. Thank you, sir.
Okay. Brian?
Yes, sir.
Yes.
Good morning, sir.
Morning.
I want to ask, how did we determine the LCM there? I'm not getting something right.
Where?
From
Now,
where
the
we saw
LCM is like when I have 1 out of 2 minus 3. Brian, what is your LCM here?
1 minus, there is
1
2,
out of 2 minus 3. What could be your LCM?
is 2.
Is 2. How did you get 2?
I made 3 also to be a fraction of 3 over 1.
Uh-huh. Have you
Yeah,
now
then
understood? Why
yes, I've
here?
gotten. Thank you.
Okay.
I've picked up.
Okay. All right.
Okay.
Miss, is it? I don't know that Mish. Miss or Miss? Okay. Okay. We can look at another identity. I think that's number 4. Remember we are just proving, eh? So I have 1 plus sine theta out of 1 minus sine theta. And we want to show that this is the same as sec theta plus tan of theta squared. Now, like I'll say that mathematics is a continuation. That the knowledge you learned in the previous topics, you may find that they are going to be used in the topic that you are covering now. What does it mean? That for whatever topic you cover in math, make sure you understand it because you may find it affecting another topic that you are going to meet in the future. If you are doing math and you are doing physics or any other, even other subjects, you may find that the knowledge you have learned here is also applied in the other side. So it depends. Like I've said, always one side can be easier than the other, but you can either come from any side of your choice. Now, members in the chat, suggest should we come from left to the right or we come from right to the left? As Dollar, as
Yes, good morning, sir.
morning.
On the previous question, number 3, you manipulated from the right, but you said you were gonna manipulate from the right, then do the one of the left also. But you skipped it, and you went to number 4.
It is okay. Now, I can briefly take you through the right. But like I've told that whatever route you take, remember the thinking is going to be different. Now, when I come from the left, I know very well that what is sec squared. So I know that sec squared theta is the same as 1 out of cos squared theta. Now, once you reach here, you are going to remember that what is cos squared theta? You know from this identity that cos squared theta plus sine squared theta is equal to 1. But since there is a cos squared theta, I'll take it to the other side. So I know that since I have cos squared theta, now I'll know that cos squared theta is the same as 1 minus sine squared theta. So now I'm going to come here and say this is the same as 1 minus sine of squared theta. Now, after reaching here, this is where I've said that the thinking is going to differ. When you look at where you are heading, you have a cosec theta. So you are going to ask yourself, what can I do? Now, let me ask members in the chat. Members, if you... Oh, okay, let me...
Yes.
Okay, now, you know very well that in math, if I have 2 out of 1 plus, let me give this one. If I have 4 out of 2 plus, no, let me give this one. Let me give another one. I want something that is going to make it a bit easier. If I have 6 and I have 1 plus 2. Members, what is your answer in the chat? Tell me, what is your answer there? Okay, ma'am. What is your answer? Which answer do you have? Members are saying it is 2. Very good. But do members also know that this number here, I can as well do the other math, even if it is 2 plus 2. Members, what is your answer for that? Now, I'm taking you. Let us move together. What about when I have 6, 2 out of 2? What is your answer? There is a direction I'm taking you. People are saying 1.5. Okay, very good, very good. Now, members, I want you also to know that in math, I could as well simplify this differently. That this is 2, this is 2. So I can decide that if I get this number, I can divide. You are seeing this 2 and the 2. I can decide to divide here by 2, by 2, by 2. As long as I have divided that fraction by the same number up and down. Here, members, I'll have 6 divided by 2, which is 3. Out of 2 divided by 2, which is 1. 2 divided by 2, which is also 1. And my answer will be 3, 1 plus 1, which is 2. I can simplify in that form as well. Members, have you got that? Have you obtained that? How I have divided? People have said yes. Now, allow me. Since where I'm heading, I have cosec. Members, I can as well come here and I say, I can divide here by the same thing. I can divide here by sine theta. I can divide here by sine theta. I can also divide up by sine of theta. As long as what I have divided in my fraction is the same throughout, then it is okay. So I can divide, so I'll get 1 out of sine of theta. Divide by 1 out of sine of theta minus sine squared theta out of sine theta. Now, what are you going to notice? 1 out of sine theta is what we call cosec theta. Divide by 1 out of sine theta is still cosec theta minus sine squared theta out of sine theta is sine theta. So this is sine theta. So that's how you can come from the left going to the right. And we have also proved it. Okay, let me hope I have answered your item. So you can prove it that way. Even if the denominators are not the same, you could as well use that approach. Yes. Okay, now we are going to continue to the one. So members here suggested that we start from the left. Not so? Kindly, someone can remind me, but as if I saw, members were suggesting we start from left-hand side, left to the right. Okay, so I'm going to start from the left, going to the right, but also I will bring you back from the right to the left. Now, when you look at the left to the right, we have our 1 plus sine theta out of 1 minus sine of theta. Now, when you look at where you are heading, you note that there is nothing in the denominator. You must think quickly. Ask yourself, how can I eliminate what I have in the denominator? In senior 5, the first term, you looked at what we call, you looked at rationalization. I want to let you know that rationalization can as well apply in trigonometry. Whenever you want to eliminate something you don't want, you rationalize. Even in your friendship, in those groups you have of friends, if you don't want anyone in your friend group or in your circle, you can rationalize the person and remove the person. Now here I am going to rationalize such that this thing I have in the denominator, it goes away. So I'm going to rationalize by saying I multiply by 1 out plus sine theta out of 1 plus sine of theta. Members have not changed anything on the equation because these two can easily cancel and I remain with the same thing. Mind you, whatever step you are doing, it shouldn't change the original identity. Now, what am I going to have? You can note that here, I'm going to have now 1 plus sine of theta. I multiply it with 1 plus sine of theta. When I look down, I have 1 minus sine of theta into 1 plus sine of theta. Now, the level you have reached at, there are some things you have to do automatically. There are some things that should come naturally. Now, take an example. Members, when you look down, you have 1 minus sine theta, 1 plus sine theta. Quickly, place your answer in the chat. Which answer do you get? Hey, now mathematical eye. Quickly, what answer do you get? Mm-hmm. Mm-hmm. Members are saying 2, 0. I want you to apply. Remember, I want you now to apply this knowledge. A squared minus b squared, what is it equal to? That a squared minus a squared is a plus b, a minus b. So compare that your a, for this case, is 1 plus sine of theta. Your a is 1 minus sine of theta. So what do you get as the result? Your a is 1 squared minus b, which is sine squared theta. So this gives you 1 minus sine squared of theta. Members, is that fine? Okay, thank you, Mark. Is that step fine? Or you can open the bracket. You can open. Members, can I assume that is okay? Okay, people are saying yes. Okay, let me first pick a hand from Anita. Anita?
Good morning, sir.
Morning.
I thought when you're rationalizing, we rationalize using the denominator. But here
Yes, and
you
that's what
use,
we have used.
I thought it's supposed to be 1 minus sine
But in the
theta.
denominator, we have 1 minus. So we can't have a minus again.
Oh, I
You have
see it
seen?
now.
Okay, yeah. And
Thank
members, okay. And I want also to let you know that even you can reach a time when you are rationalizing the numerator, depending. Remember here it is thinking. So here, now members, you agree with me that when I multiply what I have up, I'll end up with 1 plus sine theta. But since they are the same, that will be squared. Then down, we have agreed that we get 1 minus sine squared theta. Then from your identity, you remember 1 minus sine squared theta, what is it equal to? Members will agree, all members already know that it is the same as cos squared theta. You get it from here that sine squared theta plus cos squared theta is equal to 1, meaning that cos squared theta is the same as 1 minus sine squared of theta. So, but this is squared. Now, I want you to know this mathematics as well. You know very well that cos squared theta means cos theta times cos theta, which we can write it mathematically as cos theta everything squared. So, at this next step here, I'm going to say that this is the same as 1 plus sine theta everything squared divided by my cos of theta everything squared. Now, in your indices, when you are covering indices, still senior 5, you say that when I have a out of b squared is the same as a squared out of b squared. Now, we are going to move from this side, come to this side. So that means that I can write this mathematically as 1 plus sine of theta divided by cos of theta. Since the squared is the same, I put here a square. What are we coming up with? you know very well that this cos, like when you are sharing, like when I have, let me say, this is Hannah and maybe this is Dorothy, and they are sharing into two equal parts. It means you can say Hannah will get a half, but also Dorothy will get out of two. Whatever thing you are sharing down here. This cos theta is shared by two things. Is shared by the one and is also shared by the sine of theta. So now we can mathematically write it as 1 out of cos of theta plus our sine theta out of cos of theta, but everything is still squared. So 1 out of cos, you know very well that that is the same as sec theta. Sine out of cos, you know very well that it is the same as tan of theta, but everything is squared. So that is how you are going to prove it. So let me pick a hand from ITEL. ITEL, ask. In case you have a question, ask. You can raise up the hand. I will pick on two questions. ITEL, I failed to get you. Okay. D.
Thank you so much, sir. Can you finally, would you expand u1 plus sine to theta squared such that us find the values and we see if it is possible to use it or it's much better
Come
to leave
again.
it. I was kind of inquiring whether we could expand our
It
1
is
plus
okay.
sine, our
Even
1
if you
plus sine theta.
expand,
So,
you are going to
yes,
end
you
up
are.
with something like this.
Yes,
Then at the end of the day, it's going to take you back.
I get.
It is going to take you back. That's why you need to look ahead where you are heading as you are proving.
Think it here.
Okay. Mary?
Okay, so like I was asking here at the beginning where I placed 1 plus sine square, 1 plus sine theta, then 1 plus sine theta. Couldn't I do like 1 times this one, the one I'm rationalizing with, and also sine theta times this sine theta, the one I'm rationalizing with?
Where? Like opening?
There, mm.
Hmm.
Couldn't I do 1 times this one, then again 1 times this sine theta, then sine theta times this one, and
In
sine
the
theta times
numerator?
one? Yes,
It is okay. It is okay. But now,
it
what
gives
does
me the
that
same
mean?
thing.
Now, that
Mm,
means that for you are going to remain with 1 plus 2 sine of theta plus sine squared of theta. Then
mm,
everything is going to be divided by cos squared theta. You are saying
mm,
something like
yes.
that. So here now, when it comes to simplifying, you are going to
Mm,
have a mathematical eye and you say, what is 1? That 1 is the same as sine squared theta
sine
plus cos
theta,
squared theta. You are saying?
yes,
Then
yes.
plus 2 sine theta plus
Mhm,
sine squared theta out of what? Cos squared theta.
mhm,
Now you start separating. You say now sine squared theta plus cos squared theta, that will give you 2 sine squared theta. So you'll have something like 2 sine squared theta plus this is what? Cos squared theta, then plus 2 sine of theta. Then everything divided by cos squared theta. Now here you can start dividing, but you reaching the final answer. Here,
mm,
it will take you some
yes.
time and more thinking to get there.
Okay then.
But also at the end of the day, you are going to notice that whatever thing you expanded is the same as 1 plus sine theta squared if you are to simplify it in a simple way.
Yes, yes, I've seen it.
Mm, okay.
Thank you.
All right. All right. Okay. But members, if you want, you could as well come from the left and you go to the right. Whatever side you come from, Yes. Ye- yes. Yeah. So, I don't know, members, do you want us also to come from the right, go to the left, or it is fine? Do you want us to go from the other side also? With both, please. Okay. Now, if we are to move sec, okay. So we had a sec theta plus tan theta. Everything was what? Squared. I think that is how it was, right? Yeah. Now, still the first thing you do is first write what is sec. Sec is the same as 1 out of cos theta plus what is sine. Tan is sine theta out of cos of theta. But everything is what? Is squared. Now, after obtaining that, you are going to ask yourself, when you look here, mathematically, I want you to remember from your math that if I have 1 out of 2 plus 3 out of 2, as long as these digits are the same, then you just add the numerators, 1 plus 3 out of 2. Or you get the LCM. So when you look at what I have inside the brackets, you can note that this is the same. LCM is cos theta. Cos theta divided by cos theta is 1 plus cos theta by cos theta is what? Is sine theta. But everything is what? Is squared. So what are you going to do next? What you are going to do next here is that you can now separate the squared. So you can now have 1 plus sine of theta squared divided by cos of theta, but everything squared. So mathematically, you know that this is 1 plus sine theta squared divided by cos squared theta. But you know that what is cos squared theta? Cos squared theta is the same as 1 plus sine theta squared divided by 1 minus sine squared theta. Now, this is where you are going to bring in now the mathematical eye, that you know that 1, like you know, a squared minus b squared is the same as 1 plus, the same as a plus b, a minus b. Now, since you have 1 minus sine squared theta, you know this is the same as mathematically 1 squared minus sine theta squared. So when you express this, it becomes 1 plus sine theta then into 1 minus sine of theta. So that is what we are going to write there. So here we shall have our 1 plus sine theta squared out of 1 plus sine theta then into 1 minus sine of theta. So what are you noticing? That 1 sine theta, here you have 2 of them, here there is 1. So one of them can cancel from up, and therefore you remain with 1 plus sine theta out of 1 minus sine of theta. So that's how you prove from the other side. But the beauty is, with proving and showing, with proving, whatever side you come from, you get the answer, as long as you can think in the right direction. Okay. Alpha, we said I want just to know that from the identity that sine squared theta plus cos squared theta is equal to 1. Now go on and make the subject of the formula. Make your cos the subject of the formula. Take the sine this side. So you say sine squared theta minus you say sine squared theta minus sine squared theta plus cos squared theta is equal to 1 minus sine squared theta. So that's what we are doing. You are making the subject of the formula. Okay. So members, I think we can continue. Samsung, you may ask. Hope members it is okay. Let me bring in some few scenarios now.
Excuse
Let
me,
me
teacher.
bring. Yes.
Good morning, sir.
Morning.
teacher, what I was inquiring on the previous slide, when you're rationalizing, why did you use the numerator, the what? Why didn't you use the denominator? Use the other one.
Which one?
The
Here.
previous one. Yes.
But we use the denominator because the denominator was a minus.
Mm.
So, and you know when you are rationalizing, the sign changes from minus to a
Oh.
plus.
Okay, I've seen it. Thank you.
Okay. Okay, so let me take back to the scenario and you first read. You first be reading this model. Yes, Barnes?
Yes, Master, my question is,
Mm.
there, there where we rationalize the from,
Mm.
Master, under which scenarios can we meet when we can rationalize the numerator? Under
Eh,
which scenario?
okay, I will give you, we shall meet some. We are going to meet some.
Okay, thank you.
It's going to come, but it will come with practice, eh?
Okay, sir. Thank you, sir.
Take now for search,
Mm.
let me just be sure. For search, okay, I will show you one. I will show you one at a later time. But for that, for the other first one we did, in case it was
Yeah.
reciprocated, you would have rationalized the numerator. In case it was reciprocated, you just get that identity we are working on and reciprocate it. Just change.
What?
Just
Yes. Like,
reciprocate it. Turn what was up down and what was up down.
then I rationalize the numerator.
You'll find that now you have to rationalize the numerator.
What if I reciprocate and I rationalize the denominator?
Now, it may not come out.
Okay. Thank you,
Eh,
sir.
all right.
Mm.
Okay. Have the members read? Are we good to start? Are we good to start? Mark, when you bring in those squared things of square root, it may disturb you. It may disturb you when you bring in the square roots. What? No. Uh, Card, please take note. We don't have any. This is not mathematically correct. This is not mathematically correct. It must just be squared. It is when it is squared that is equal to 1. Okay. Those identities, you must be knowing them in the head. Most of the first three we looked at, they must be in your head. Here, I've just put them for you, just remind you, but they will not give them to you at all. You must first be knowing them. So we are going to start. So they are telling us that there is a telecommunication company that is designing a satellite system to improve the transmission of the signals. The strength of the signals depend on the angle between the antenna and the satellite on the ground. Those who have been to Mpoma, I think you have seen this. Those who have been to Kayunga, those ends, we have a satellite there. But now the engineers have come up with the two signal amplification models. This is the first one and this is the second one. But before they finish the designing, they want to determine whether both models, once amplified, they give the same values. So they have given you some more information that the angle of elevation measured from the horizontal and the rest of that. But they want us to investigate whether the two models for the amplification are equivalent. Whether these two models are what? Equivalent. For all the values of what? Theta. And that's what now we are going to do. Now here, indirectly, they're asking you, when you look at model 1, and model 2, are they the same or they are different? Because if they are different, it means that the amplification value, the angle of elevation is going to be what? Different. So the two models would not work. So that is what we are going to work on. Members, are we on the same page? Kindly let me know such that we can start. Now, I want to first put this and I let you know if you want to enjoy mathematics, if you want to apply and learn how to apply math, let us disease it, if possible, from using the logbook. Number one, the logbook is going to waste a lot of your time when you are answering the paper. Let me say the paper is for 3 hours. For whatever formula you want to run to the logbook, you are going to get like you are going to find challenges. Number two, the next level you are going to, they don't give you those formulas. You must be knowing them in the head. I know your brains are still very young. I know you can master many of these basics. The way you master the TikTok videos, the way you master those
Yeah.
dances, the way you master the moves is the same way, the same energy you need to invest in learning. Yes, that's why for me, I don't want and I don't encourage anyone to have the logbook. Let's just master the basics. Logbook, you use them maybe for those binomials. But when it comes to these formulas, first learn them and that one will mean that if you practice, those formulas are going to start flowing naturally. You'll see things flowing. Otherwise, if you don't master, you'll get stuck always. Whenever you are proving, whenever you're working with things, it will waste time because in the paper you'll find that you'll waste about 10 minutes checking where is this, even if you have crammed the page. So away completely. And now first say, can I have them in the head? And I trust you can have those things. The way you master those songs, the way you master the what and the rest, those stories of yours, you can surely master them. Yeah. So we are good to start. Now, what are we going to investigate? We want to show whether the first model is the same as the second what? The second model. That is what the question wants us to investigate. So, which side do you want us to come from? That one also matters. Where do you want us to come from? People want us to come from the left. That is Mark Kisacha. Okay. Oh, I think I didn't okay. Can I write on the same screen? Oh, it might be a bit lengthy. Let me create a slide here. Let me create a slide here. Now, what do we have? Now, we have been given for our model 1, we have our tan of theta plus cot of theta out of our sec of theta plus our cosec of theta. What are we going to do? Now, when you look at the second model that we want to show, that model has sines and cosines. Mean that whatever thing we have here, we must write it in terms of the sines and in terms of the cosines. So you start slowly. That what is tan? Tan is the same as sine theta out of cos of theta plus what is cos out of sine of theta. Then everything divide by sec is the same as 1 out of cos of theta. Are we still on the same page? Still on the same page? SP10, that one. We are still on the same page. Now, When you look at what we have, I want you to look at this part here. You notice that you have sine of theta out of cos of theta plus cos of theta out of sine of theta. Now, when you look at it, you notice that your LCM is cos theta sine theta. That is your LCM. Now, what are you going to do? Get your LCM, divide by cos theta, like having cos theta sine theta, divide by cos theta. So this and this cancels, so you remain with sine theta. So we are going to get sine theta times sine theta, which is sine squared theta, plus cos sine theta divided by this is sine times cos. We get cos squared of theta. Alternatively, someone can just cross multiply. Cross multiply sine times sine is sine squared theta, plus cos times cos is cos squared of theta. Then everything multiplied by cos theta sine of theta. So that is what I'm going to write up here. So my numerator is going now to become sine squared theta plus cos squared theta out of cos theta sine of theta divided by what I have in the numerator, in the denominator. So in the denominator, I have cos theta plus 1 out of sine of theta. So mathematically, still you can use the cross multiplying. This multiplies here, this multiplies here. So I get sine theta plus cos of theta. Then down I have cos of theta, sine of theta. So here I'm going to come and I have sine here of theta plus cos of theta divided by cos of theta sine of theta. Now we do the mathematics. So it is okay, you divide the two. If you are quick at math, it can come out very well. So now I'm going to have sine squared theta plus cos squared theta. I don't want to eliminate it for now. Cos theta sine of theta. I divide by sine theta plus cos of theta. Divide by cos of theta sine of theta. So this will give us sine squared theta plus cos squared theta. I want to take it away. Cos theta sine of theta. Then times cos of theta sine of theta out of sine of theta plus cos of theta. You are not saying that this and this will cancel. You know that sine squared theta plus cos squared theta is a 1. So I remain with 1 times 1 out of sine of theta plus cos of theta. And when you look at this, you notice that our model 2 was that. And therefore, you are going to conclude that since model 1, what you get for model 1 is equal to what you have for model 2, then it means that you will get the same signal amplification factor. Yes, so that is how you approach it, members. No, Hawking, is it Hawking? I've said here we are not cross multiplying. Here, this is just the technique. It is just the technique. Multiply here, multiply here. So you get 1 times 3, 1 times 2 out of 2 times 3. It's not that cross multiplying should be only for what? For equal signs. No, 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 no. I'm not getting tan plus cot. Where is that now? No, you need to know that tan of theta is the same as sine theta out of cos of theta. Then you need to know that cot of theta is the same as cos out of sine. That is what you need to know. Yes, Mua, it is very possible. You may prove and things are not the same. Then there you need to conclude well. Your conclusion matters. Since model 1 is not equal to model 2, then this and this can happen. What is the last step? The last step, I repeat, here sine squared plus cos squared theta is 1. Remember it from the identity. So here you get 1. So 1 times 1 is 1. Here use the 1 times sine theta plus cos theta, which is that. Just know sine squared plus cos squared, always you get answer 1. Even I could have placed it here that 1 out of cos theta, sine of theta. That one is also okay. Okay, I'm going to pick on a few hands. Itel and then Holoman.
Sir,
Yes,
good morning, sir.
morning.
What if I get the LCM here where there is cos theta plus cot theta out of cosine cos theta out of sin theta, and I get the LCM. Then I divide using the LCM.
It is also okay. Here, like getting the LCM as cos theta sine theta, then you multiply cos theta sine theta, multiply here cos theta sine theta, multiply here cos theta sine theta, multiply here cos theta sine theta. That is okay. The sine and the sine cancels, the cos and the cos cancels. Yeah, that is very, very okay.
Okay, sir.
That is very, very okay.
Morning, teacher.
Morning.
Teacher, at our second step where we have sine theta over cos theta plus cos theta over sine theta. Since we have 1, when we equate, we get 1 over sine theta plus cos theta. Why didn't we cancel out sine theta and sine theta? They go cos theta and cos theta. They go, then remain with the 1, then deal with the denominator alone.
Come again, come again.
Our second point, the second step, we have sine theta over cos theta plus cos theta over sine theta, right? If we cancel out the sine theta and the sine theta, that's a 1, cos theta and a cos theta, that's a 1, which is the same as the numerator of what we are equating to.
Okay, are you seeing what I've put on the screen?
Yes.
What is your answer?
2.
2. Here, your answer you are saying is 2, right? How are you getting 2?
The 2 and 2 go, 3 and 3 go, then actually it's a 1.
Okay, get your calc. What is 2 out of 3?
2 out of 3. What to divide by 3?
Okay, 2 divided by 3.
0.66 recurring.
Plus 3 out of 2.
1.5.
So what is your answer?
2.16.
2.16, eh? Now I'm giving you this. 2 out of 3 times 3 out of 2. What is your answer?
1.
1. So, is this one and this the same?
No, I get it now, teacher.
Okay.
Thank you.
Okay. Okay. Now, we cannot leave here minus first trying out. So, we are going to pick the first one. Can everyone, now we have some time, right? Number 1, can everyone first start with this one? You prove that this side is the same as that one. Quickly. Any that will fail is what we shall go through together. But here, I want us to first do one on our own. Comes out, place in the chat that yes, it has come out. We on part A. Okay. If it has come out, can you go to part B? Okay. Has it come out? We are on part B. When it comes out, please just know how things are. Yes. We go to part B. Hey, someone wants me to show. Yes, now for part B, it will be cos x. Let me get a better pen. So part B is going to be cos x tan of x. So we should be cos x tan x is sin x out of cos of x. So the cos will cancel. So it remain with sin x. Yeah. We on part B. We on part B. B is done. It has come out. Can I get your hope? Who's C has failed here? See, B has come out. B has come out. B has Who's taking us through B? Quickly. Someone to give us a hint on B. I want someone who is taking us through part B. Azri, okay, Kayondo.
So part B, we are having 1 minus cos squared x over sine x over sine x cos x, which is equal to tan. So we are starting from the left-hand side, where we have 1 minus cos squared x is equal to sine squared x. And of which, if you transfer that sine x squared, sine squared x over, when you have sine squared, is going to be sine x times sine x over sine x of cos x, of which if we're having sine dividing with sine, we shall remain with sine x over cos x, and of which is equal to tan x. Clear?
Okay. Hope that is okay. So that one has also come out. Why are people saying? Which part has refused? Has part C come out? Who's taking us through part C? Thank you, Kayondo. Who's
Welcome.
taking? Yes? Who's taking us through part C? As if people are saying part C is not coming out. What's not happening? Part C. Part C has come out. Raise up. In case part C has come out, you raise up. Mwesgwa. Joshua? Okay, Joshua is not coming out. Joseph?
Now, for part C, you
Mm-hmm.
first get cos x is equal to cos x equals to 1 minus sine x.
Oh.
After that, you rationalize you rationalize 1 minus sine x on both sides.
Okay. So here you multiply by?
No, you first change cos x into 1 minus sine x squared.
Oh, okay. You want 1 minus sine squared x out of
Yeah,
1
out of
minus.
1 minus sine x. Then
Okay.
You
Okay.
rationalize changing the sign on the upper side.
Okay.
After rationalizing, then down you'll get difference of two squares, which will give us each squared.
So here I'm going to rationalize.
Yeah,
So here I multiply by 1 plus sine x, like that.
yeah. Even here,
Uh-huh.
yeah. Now the denominator will be 1 minus sine squared x
Okay.
plus what, like that. Then this bracket will go, the other one will remain with 1 plus sine x.
Wow. Perfect. Thank you. That is from Kayondo.
Okay, teacher.
Yeah, that is good. This number members, it had another approach. Hey, like we have said, we can Mark Chisache, the second approach for that same number.
Yes, teacher. I had
Mm-hmm.
cos squared x, and it was the
Mm-hmm.
same as 1 minus sine squared x over 1
Okay.
minus sine of x. Then
Uh-huh.
for the numerator, I used difference of two squares,
Uh-huh.
where I had 1 minus sine of x into brackets, and again 1 plus sine of x into brackets,
Okay.
over 1 minus sine of x.
Okay.
Then the 1 minus sine x cancelled, and I
Uh-huh.
remained with 1 plus sine of x.
Okay. Perfect. Thank you. Thank you. Okay. Uh-huh. Members, we are on which part now? Part D. I want one part that has failed. That's the one I want us to do. Ah. We have done B, Marion. For B, we have done. Now we on part no, we have done D, yes. We on part D or E. Yeah, we are doing those ones.
Good morning, sir.
Yes.
I beg your pardon on part C. I think I didn't get it right.
On part?
Part C.
Part C.
Mm.
Which area?
Because I tried rationalizing, many things didn't come out well. As if it's giving me the same thing up and down.
You tried rationalization, eh?
Mm.
Now, the choice of the approach to use matters a lot.
Mm.
So what were you rationalizing on part B? On part what?
Part C.
Part take us through how you rationalize.
Okay, I had left hand side is equal to cos squared x out of 1 minus sine x. Then the next cos squared x out of this one, I rationalized it by changing the minus sign to a plus sign. So I multiplied 1 plus sine x up and also 1 plus sine x down.
Okay.
Then I changed cos squared x using the identity to give me 1 minus sine squared x. So I was multiplying 1 minus sine squared x times 1 plus sine x out of 1 minus sine x times 1 plus
First
sine
simplify for me what you have in the denominator.
denominator. Hold on. It's sorry. 1 minus sine squared x.
1 minus sine squared x. Are you seeing something crossing?
Oh, yeah.
Okay.
Absolutely. Thank you, sir.
Okay. Members, any DS part D has come out. E has come out. D is yes. Okay. Allison.
Yes. Teacher, I'm taking you through part D.
Okay. Part D.
So I'm coming from the right hand side. So I said cos x plus tan x. So I changed the tan into terms of cos. And we know tan x is the same as sin x out of cos x.
Okay.
So, but from our identity, we know that when you find the LCM, because cos x is out of 1, our LCM becomes cos x.
Okay.
And when you get cos x divided by 1 and then you multiply with the cos x, you get cos x squared plus sin x. So we change the cos x squared into terms of sin x squared by getting 1 minus sin x squared.
Okay.
Plus sin x out of cos x. So mathematically, we rearrange that. We get 1 positive 1 plus sin x minus sin x squared out of cos x.
Okay. Yeah.
Yes, that's
Thank you,
the one.
Alison. Yes. And
Oh,
Alison, why do you think in real life we arrange it like that?
I think because positives should come before that negatives.
Okay. That it is always better in life to meet a positive person first than you meet someone who's negative. Just imagine you have just woken up early and the person you are meeting is negative, is telling you bad news, bad news, bad news always. Now that one can spoil your day. So always prefer that you meet positive people first before you meet someone who's negative, before someone spoils your day. Okay. Now members, unless a number here has failed, but if E yes, members have said E is yes. Lastly, F, I want someone, if we can get one person. Gabby and Praise.
Teacher, I'm asking something small about the previous explained number, part D.
Oh, yes.
When he was explaining that part where he said cos squared x, then when he came down, he said 1 minus sin squared x. Like, how did it come about?
Come again, come again.
Cos squared x
Hmm.
in the numerator.
Hmm.
When we went to the next step, it became 1 minus sin squared x. How did it become that?
Oh, like we had cos x plus sin x out of cos x, right?
We had cos squared. Yes, yes.
Hey, so like here, it is still cos x. There is nothing like cos squared.
Up.
Hey, up, eh? Like here,
Mm.
the LCM is cos x, eh? So cos
Mm.
x divided by 1 is cos x. Then times this one up.
Oh.
Hey.
Then the next step,
The
1
next,
minus z. The next
hey.
step.
Then that one comes from the rule that sine squared x plus cos squared x is 1. So where there is cos
Oh,
squared x, you make it the subject.
okay. Thank you, teacher.
Okay. All right.
Teacher.
Praise.
Teacher, I didn't understand the
Uh-huh.
first step where it was 1 plus sine x and he put cos x. I thought that one works when it is only squared.
Yes, that's why he did so. He substituted for cos. Remember, it was cos squared x plus sine x. So he only substituted for this. This sine x remained.
No, I mean from the first step.
From the
It
first,
was Yes, it was 1 plus sine x minus sine squared x. Now on 1 plus sine x, he replaced it with cos x. And I thought that one
no,
only works when it is.
no, he didn't. He didn't. He, what 1 plus here, are you saying, now if for you are coming from the left, you must arrange it in this way. 1 minus sine is the cos squared x.
Oh, teacher, I've understood. Thank you.
Okay. All right. Okay.
Part
Okay.
F. I want to like go through part F.
Okay. Part F. Part F. Okay. Good. We go.
So part F, we have cos power 4x plus sine squared x cos squared x is equal to cos squared x. So we see that we have sine squared x. We're gonna change it into terms of what? Of cos squared, which becomes
Okay.
1. It's gonna become 1 minus cos squared x.
Okay.
And that's brackets cos power 2x. And then we are going to open the bracket. It's going to become cos 4x. Sorry, cos power 4x plus cos squared x minus cos 4x. And then the cos 4x and the other cos 4x are going to go away. Like they're just going to subtract themselves. It's going to become 0 and remain with cos squared x.
Wow. 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 Thank you. Thank you. Thank you. Yes, that is very, very correct. Okay. Yeah. I think unless someone has a question, Juma. Now I want now to we upgrade. How many minutes do we have? We are going to upgrade. Parison, we are upgrading. That was level 1. Now you have passed level 1. Why don't we go to level 2?
Excuse me, sir.
Yes.
What if I factorize out the cos squared of x?
Here,
Yeah.
cos squared of x, and you remain with?
Cos squared of x plus sine squared of x.
Good.
Then I know that cos squared of x plus sin squared of x equals to 1.
Perfect.
So I'll be having cos squared of x as the answer.
Perfect. Perfect. Yeah. So one thing you're going to discover, in proving, you can do anything. As long as you. Now, why don't we take a screenshot of all these numbers? Okay. Has everyone finished to take a screenshot? Olivia. Olivia? Okay. I think I'll fail to get Olivia. Now, members, what are we going to do? We are going to start from here tomorrow. And tomorrow we shall start on a new concept. Now, to prove your muscle, to prove that you have understood today's lesson, make sure that you try out all those. Now, the beauty when it comes to no, wait. As if I've given you few. Wait, don't run away. Let me first add you more. Eh, First also take a screenshot. All those are identities. But all these identities, it's just proving. Don't put them in the head. As long as you know the basics, you know the foundation, just know we shall be good to go. Okay. Hope members have taken a screenshot. Yeah. So these few numbers here. But the beauty is you are going to enjoy. The moment things come out, it will be very good. Now, where are we going to apply this? We are going to be looking at solving these equations. And for you to be able to do them, once these identities are in the head, you know how to maneuver here, and here. Things are going to be very easy for us. Let me pick Billion and Sharon, and we go.
Master,
Yes.
Master, you said the rest ends at 10.
At
But
10,
this yes.
the lesson ends at 9. We start at 7 a.m.
Master,
Yes.
morning once again.
Morning.
Master, may I like the mere fact that you gave us a scenario and we saw how to approach it. I was overview that probably every day you give us like at least 2.
Okay, no worries. No worries. We shall have them.
Easy.
Okay. Okay. So why don't we end here? Poloman, I think I failed to get you and Olivia. So I want you to practice, and let us ensure that at least we are there. I want to repeat for latecomers. Latecomers, the lesson starts at exactly 7. We don't wait for any, like we don't put any minutes that maybe we give them 5 minutes. No. So meaning that you must be able to wake up at exactly maybe 6:30, prepare yourself such that you're on time. Otherwise, sometimes
Master,
it
we take the
becomes
lesson. Let's take the lesson to 9:30.
9:30. Hope you know that I've been having a lesson from 3 a.m. So my lesson starts at 3 a.m. So, and I have another session at 9, unfortunately. I have another session coming in now.
Okay.
Kari. Have a beautiful day. Tomorrow, let's keep time. Yeah, bye bye. Bye bye.